Hello, this is John from caveofprogramming.com. This is, we're up to tutorial 19, I think, in the design patterns course from Cave of Programming, Java design patterns. And in this tutorial, we're going to look at the adapter pattern. So I've got a project set up here in Eclipse, and I'm going to show you an example of the adapter pattern. And the idea behind the adapter pattern is very simple. It's just if you've got two interfaces, like you need one interface and you've got another class that has a different interface and yet provides the functionality you want, you can use an adapter class to match one interface to another, and that's all it is. And I'm using interface in the broadest possible sense here to mean just the methods that a class has. So it might literally mean an interface, or it might just be a bunch of methods with some particular interface in the loose sense of the word. Well, rather than keep talking, I'll show you an example. Let's imagine here that we've got a class called logger. Let's create a class called logger. And I'll give logger a method like public void write, and write accepts a string. And then what it should do is it should write the string somewhere to a file or to the console, or to a database or something like that. Now let's imagine that logger needs another class. It has a dependency on another class to actually do the writing. And let's say that that class implements a interface. Let's say public, what should we call the interface? Let's call it log writer. And I'll call that variable log writer. And then write just calls log writer dot out to output the text somewhere. Let's create this interface here, this log writer interface. So I'll create a new interface called log writer, and we say that the interface specifies that any implementing class must have a public void out method that takes a string. So I'll save that, and so this is fine now, and the way we'd use this would be in a main program. We could declare a logger like this, equals new logger, and then we could call logger dot out and output some text like hello there, like that. So did I get that? Yeah, it's actually logger dot write, so logger dot write, like that. Okay, so this program compiles. So we're creating a logger, we're calling logger.write, and if we look at logger, indeed it has that method write, but it needs somehow to get this log writer to actually implement its functionality. Let's give it a constructor. Let's say public logger, which accepts a log writer, and then it sets the instance variable, this .log writer, using the value passed to the constructor. All this is completely standard Java, and now we need to pass in some class here that implements that log writer interface. Let's imagine that we have got a class. Let's create a new class here, and I'll call it console writer. And now the interface log writer, it has a method called out. Let's imagine that console writer writes to the console, but with a method called, let's say, write console, and it takes a string, and what it does is it just does sysout like this, text like that. So a very simple class. Now the point here is, this is a little bit laboured, but the point is that we've got a class here that expects a class that implements this interface here, and we actually have a class here that implements the functionality that we want. It just doesn't implement the interface that we want, because this has a method called write console, and this interface has a method called out, and logger expects something that implements that interface with a method called out. So it's quite a simple example really, and it could be a lot more complicated than that. This logger might want a class with all kinds of different methods. And we might have another class that, yeah, does implement that functionality, but just doesn't have those specific methods. So how can we fix that? And the answer is we write an adapter class. An adapter class could be anything that adapts from this interface, in the wide sense of the word interface, to the interface that we actually need, which in this case is this one. Let's see how we could do that. There are two basic ways to do it, one through composition and one through inheritance. Let's take a look at composition. I'll create a class here called console log writer, and we'll say that console log writer indeed implements the interface we want. So it implements log writer. That's the interface that we actually need. Let's save that and add the unimplemented method here. And now we could, well, where do we get this functionality from? The functionality can now come from this console writer. So using composition here, we say private console writer, console writer, let's say. Let's here say equals new console writer, or I could do that in a constructor, of course. And now we can say console writer dot write text. So this class is simply composed of this class, basically, and actually doesn't even have anything else in it apart from this method that uses this class, this object. So now in logger we can, in app.java, when we create a logger, we can say here console writer, getting mixed up, console log writer equals new console log writer, and we can supply it to the constructor log writer. There we go. Save that, and there it goes away, and let's run it and see if it works. And it works. It says hello there. So although you could easily get lost in all these different log writers and console writers and whatnot, the idea is really simple: to adapt one interface to another by using an intermediate class. And in this case, the intermediate class has as instance data, it has an object of the type of class that provides the functionality, and its sole function is then to implement the right interface and to use this object that we couldn't originally use to provide the functionality. Well, that's of course not the only way we could do it. Let's create another class here, another class, and I'll call it console log writer 2. Click finish. Not really a good name for a class, but it'll do. And let's say that extends the class that we can't use, which is this console writer class. Extends console writer, and I'll also say implements log writer, and let's add the missing method there. And now we can just use a method from the parent class, write text. So because it, have I got this right? Let's check the console. Yeah, it's write console that we need. Write console. So this extends console writer, and so inherits its method. It extends the class that we can't use, but it additionally implements the interface that we want, and then it implements that interface using the functionality that it's already got, because it's implementing the class. It's extending the class that has that functionality. Let's save that. And now, again, we could, in app.java, we could do that again. Let's copy this, actually, paste it, and format it. And let's say this, so this version here uses composition, and this version here uses inheritance, but they're both examples of the adapter pattern, and we'll make this a console log writer 2, and let's call that log writer 2, and this is log writer 2, and let's make this logger 2 and logger 2. So if I've got this all right, we should see some more text here. Let's say hello there too, and save that and run it, and there we go. So both examples of the adapter pattern. Well, it's already quite a long tutorial, but I want to just finish off by showing you an example of something that isn't the adapter pattern. So if you just want to know the adapter pattern, you can stop watching now. But I want to show you something that might potentially confuse you. Let's create a new class here, and I'll call this, let's call it Swing App, and I'll give it a main method, and I'm going to put a comment here, not the adapter pattern. Now let's create a basic Swing program. Well, the kind of official way of running a Swing program is to use a method called invoke later of Swing utilities. I'll just leave that out for the moment, and you can look that up, Google it if you want to. Let's just use a JFrame here, equals new JFrame. And I'll just do, I'll create a really simple Swing app. Let's say frame.setSize, and let's set it to 400 by 400. And frame.set default close operation, default close, and that just makes it quit when you click the cross in the corner. So when you click the cross in the corner of the frame, or on Windows or whatever it is on Mac, I forget, even though I am on a Mac, then you want the program to quit. So let's say jframe.exit on close, and now finally we can say frame.set visible true. So this is a basic Swing application, and if I run this, save it and run it, click run, we get this window appearing here. So, and yeah, I can click this red thing on the Mac, this red cross here. It's still a cross in the corner anyway, and it quits the application. Now, there are all kinds of things you might want to do with JFrames, but one thing you could do, for example, and this is quite common, what I'm about to show you is quite common in Swing, is you could set a window listener to listen to it. So let's say I want to know when this window opens, or you might want to know when it closes, so you could close a database connection or something like that. We can say frame.add window listener. I think that's right. Yeah, add window listener. And so now we need something that implements the window listener interface, and I could use an anonymous class syntax here, which hopefully you're familiar with, and if you're not, you can find that in my Java for Beginners course, although it is a little bit advanced, but that course is free as well. So let's say here, new window listener, and open a bracket here, and the bracket closes there, put a semicolon there. Now I have to implement these methods of window listener. So I click the error and go to, what's wrong with this? Let's, I think that's good. I've got add window listener, something's wrong. Let's just quit that, do control space. Yeah, it wants a window listener. So did I type something wrong? New window listener, put the brackets in, save it, add the import, that might help. And then I click on the error, and come on, let's get this working. So tedious. Let's make sure I've added the right window listener import. Yeah, there is only one. And finally, okay, I don't know what's going on there, but I can now go to add unimplemented methods. Now the point I want to make here initially is that this window listener interface has a lot of methods. Look at this, it's terrible. All I want to know is when does the window open, and just to get that information, just to implement window opened, I've got to have all these dummy methods sitting there. So Swing provides, in this case and in many other cases connected with mouses for example, it provides a class called window adapter. Let's delete this and say here, new window adapter. And again, I use an anonymous class syntax. Let's add the import there. And now the error goes away. And the deal with window adapter is it's simply a class that implements the window listener interface with dummy methods. So now in here, I can override the methods that I want. I can go to source, override implement methods. Let's try overriding window opened here. That will probably work. And now in here, I can put sysout window opened. Is that how you spell opened? I'm going crazy. Opened. I think that's right. Okay, my brain's getting a bit overheated, but we'll run that and whoa, and close it. And yeah, it says down here, window open. So we detected a window opening event. Now, what do you notice about this window adapter? Well, you might have noticed that it doesn't implement the adapter pattern. And I did a bit of Googling because I was curious as to why it would be called window adapter. Or is it implementing the adapter pattern in some way that I can't quite tell? I suppose you could say that it's not taking a interface and matching it to another interface, strictly speaking. It's just providing a dummy implementation of an interface. As far as I can see, it's not really the adapter pattern, and you could sort of argue that it is. It is helping you implement a interface by adapting another interface that wasn't ideal for your needs. In a sense, I suppose it is at a stretch, but it's not what we think of as a normal implementation of the adapter pattern where you're matching one interface to another or one class's methods to another class. And I did a bit of Googling, and people seem to be saying on various forums that the deal is that this window adapter was written before the adapter pattern as such was really in people's consciousness, or maybe even before it was named, I don't know. So it's just that this is kind of misnamed, and there's some debate about what pattern this actually implements, and I found one guy saying it implements the null object pattern. I don't really think it does, because as far as I understand it, the null object pattern is where you have an object that exists only to define the state of null or of there not being a value for something. So I don't know what pattern this is. At a stretch, it's the adapter pattern, but not really. So you might be confused by that, and if you are, don't worry, you're not going crazy. It's just that this is probably written before the adapter pattern was really prominent or thought of widely. I don't know, something like that. It's kind of misnamed. So that's it for this tutorial, and there's still some more patterns to cover, so I hope you'll join me again for the next tutorial. And as always, I put the source code on caveofprogramming.com. So if you go to www.caveofprogramming.com, scroll down, you can either choose to view this tutorial series at the moment on udemy.com, and there's a link with a graphic at the top of my website homepage at the moment for that, or scroll down to the YouTube videos and you'll find also a link to the source code there in the appropriate tutorial. So until next time, happy coding.